Hi everyone, welcome back to my channel, and in this video we'll dive into the one of the most revolutionary technologies in artificial intelligence, that is neural networks. So let's get started. Neural networks are a yeah. So, neural networks are the powerful machine learning technique inspired by the structure and function of human brain. They excel at recognizing patterns, making decisions, and solving complex problems by learning from the data. We learn how they work, and why they are so powerful. Plus, we'll implement it in a simple neural network using Python and classify handwritten digits from MNIC dataset. So let's get started. Now think of neural networks like a web of road connecting different cities, where each road transfers information and together they work to find the best path to the destination. Or in our case, the best prediction. Now, what are the fundamentals of neural networks? So, firstly, the basic architecture. The basic architecture is inspired by the human brain itself. It has nodes called neurons, and they are organized in layers such as input layer, hidden layer, and output layer. We'll understand about it later. Now, learning processes, that is neural network learns by adjusting the strength of the connection between neurons, allowing them to recognize the patterns and make accurate prediction. Next on, we have the biological inspiration. Inspired by the brain, that is a neural network modeled after the biological neural network found in human brains, with nodes representing the neurons and connection representing the synapses. So, let's consider a simple example where if you put your fingers into a really hot water, boiling water, so you will just take your hands quickly back outwards. But why? Because you have your synapses, and it triggers your brain, and then it gives instruction to like take it back. And how it works, it works by the interconnection of one neuron inside a in the blood vessels, and then it goes to our brain. This is the more biological inspiration. And about the parallel processing. So, like the brain, neural networks works, processes, and information in the parallel, allowing faster and more efficient consumption. Adaptability. Neural networks like the brain can adapt and learn from the experience, making them highly flexible and capable for handling complex and non-linear problems. Now, perceptions of multi-layer and other perception. Now about perceptrons and multi-layer perceptrons. So perceptron are the basic building blocks of neural networks, a simple algorithm that can learn to classify input data into different categories. Multi-layer perceptrons, and the MLPs have multiple hidden layers, allowing them to learn more complex and abstract representation of the input data, making them a powerful than a single layer perceptrons. Now, activation functions. Now, there are some popular activation functions in neural networks. That is, firstly, sigmoid. So, sigmoid function is commonly used in activation function that introduces non-linearity and squashes the output between 0 and 1. ReLU, that is rectified linear unit, is another popular activation function that outputs the input data directly if it's positive, otherwise and otherwise zero if not. 10H, that is the hyperbolic tangent function, is similar to the sigmoid function, but it outputs between -1 and +1, which can be advantageous in some applications. And lastly, we have softmax function. So softmax function is often used in the output layer of neural networks for the multi-class classification task, as it produces a probability distribution over the classes. Next on, we have back propagation algorithm. So firstly, we have forward pass, where the input data is fed. So now let's learn about the back propagation algorithm. Firstly, we have forward pass, that is input is fed through neural networks and the output is then calculated. Next on we have error calculation, that is the error between the predicted output and the true output that is computed. And lastly, we have back propagation, that where the error is then propagated through the networks and weights are adjusted to minimize the error. Next on applications of neural networks. So neural networks are very versatile technique by the machine learning, and it is used in various sectors such as image recognition, where the it is probably excels in image classification, object detection, and image segmentation. NLP, that is natural language processing, so such as chat gpt for example. So they are widely used, neural networks are widely used in this type of processing. And we have text classification, machine translation, or chatbots, for example chat gpt as mentioned earlier. Predictive analysis, that is neural networks excels at making predictions from stock market and forecast to weather predictions and beyond. And lastly, we have speech recognition, that is, it converts spoken language into text, powering voice assistant and other special based applications. Now, future of neural networks. So firstly, as neural network continues to evolve, we can expect to see advancement in computational power, hardware, and networks architecture, leading to the broader and more impactful application. However, the increasing influence of neural network also raises the important and ethical consideration that must be addressed. And this is our chart. You can see increased computational power, advancement in hardware, improved architecture, broader application, and ethical consideration, that it must not go under false or uh, under false or some cyber crimes. So that's it for now. Let's move to our coding part. Okay, so now let's discuss the key components of neural networks. Firstly, we have input layer that takes in the features or the data for processing, that is, accepts the input features of data. Secondly, we have hidden layers. These are the layers where the magic happens. That is, they process the data and identify the patterns using weights and biases. Next on, we have output layer that produces the final prediction, like an image, like whether the image contains a dog or a cat. There is more to it. That is, we have activation functions that introduce non-linearity into the model, as we discussed earlier, helping it to handle complex patterns such as ReLU and sigmoid function that were discussed earlier. Next on, we have loss function that measures how far the predictions are from the actual values. Examples include mean square error and Krauss entropy loss and many more. Then optimizer, that is, updates the weights in the network, minimize the loss. So this was our code. Now let's try to run this code. It was just installing, and then accuracy and loss and values, and it will take a bit time. So we have done hidden layer and hidden layer, two hidden layers, and then one output layer with 10 neurons, and then compilation the model, and then training the model with x train model with validation split of 0.2, and then equivalent batch size. And then it is taking time, so let us wait for a minute. So this is our output, where we have trained uh, the model for 10 epochs, that is iteration through the data set, and then use a batch size of 32 for better memory efficiency, and then set aside 20% of the data for the validation to the monitor during the training. Now, during training, the model learns to minimize the error and improve accuracy. We can also visualize training versus validation accuracy and loss curve to check the overfitting and underfitting issues. Now, next move to our next point, that is evaluating the model on test data. So we have test loss and test accuracy, which will evaluate our X test and Y test model, and then printing the model, and then to visualize the predictions, we have used Matplotlib library, and then displaying by displaying by the plot, that is IM show, and we have observing the results. We will get some insert accuracy, and then training accuracy, validation accuracy, test accuracy, and here is a look to test some images along the prediction. So firstly we'll run this. So here is some look at the test images along with the prediction. uh 1 second, yeah. So this was predicted and actual 72104. So, as you can see, the neural networks performs pretty well at recognizing digits. So, observing the result, we have training and validation accuracy. That is, during the training, we monitor how the model performs on both training and validation data set. Test accuracy, that measures the model's generalization ability to on unseen data, and then prediction, that we used on trained model to make prediction on test samples and compare them to the actual level. So that's a wrap for neural networks. We have learned how these brain inspired models can even build one from scratch to classify handwritten digit. If you enjoyed this video, give us a like and subscribe to my channel. And thanks for watching this video. Thanks for watching.